caption. So today we're gonna look a little bit on, so we're gonna expand a little bit on TCP. We'll talk a little bit about IP address, and I think most of your exercises today I'll walk you through. In IT and cybersecurity, you just have to understand what an IP address is made of, the number system that's used, right? Computer science students, they also have to go through binary octets and all of those things because sometimes they were working with, bin files or whatnot. So when you look at the notes, the beginning part of it, it goes over transmission control protocol. And I think we talked quite a bit about TCP on the protocols that belongs to TCP. But the internet is ran by transmission control protocol and internet protocol. And the IP part, like I mentioned before, it's mostly used for IP addressing. When we are looking at IP addresses in domains, right? Like for example, google.com, you're looking at public IP address. So TCP and IP, it allows us to be able to interconnect with different types of systems, even though they're made of different manufacturers, different hardware companies producing these systems. All right. So let's kind of look at the IP address. When you are look at version 4 IP address, for example, at home, you might have 192.168.1.15, for example. This is a version 4 IP address. This IP address is made of 32 bits, right? And it is in each of the number before the period or the dot represents an octet. So each of those value is equivalent to your 8 bits. And so if you take 8 plus 8 plus 8 plus 8, you get 32 bits. So the 192 here is a decimal number. Okay. And decimal number is what we use for counting, right? And math, for most part, right? When we learn how to count. So that 192 needs to be converted so the computer can understand the binary value of that. So the switch, when it sees, the router, when it sees that IP address, right, it would then convert all of that into a binary value. So you would have one octet that represents 192, the second octet that would represent 168, and the third is representing the 1 and the 15. And remember that this is decimal numbers, right? That represents the 32-bit in the IP address. So the first question asks you, how many bits are in an IP version 4 IP address? And that will be 32 bits total. Okay. Now, how many octets are in IP version 4 IP address? We mentioned that there are 4 octets, right? Octets is made of 8 bits. So if you take 4 times 8, you get 32 bits. So there are 4 octets, and they are each separated by the dot or the period, right? We say dot, we don't say period. The dot in the IPv4. And there are 8 bits per octet. Okay. Any question? Now, IP version 4 supposedly should be phasing out, right? In 2011, IP version 4 in the world, the public IP, the list of public IP had ran out. Now, why are there still IP version 4 IP addresses being used? Because there are existing systems that use it. Cloud company like Microsoft, right, AWS or Amazon, there are many companies that have a very large list of public IP addresses for maybe cloud infrastructure or even mobile devices, right? Because the scale of mobile devices is exponential. We see that, we have to start using more IPv6. And eventually down the line, you're going to see the IPv6 will run out, right? As the world have more technology that needs to have more IP. Now, when you look at an IP address on your home systems, like what we've seen with the 192.168, this is a private IP address for that network, right? So what happens is inside the network, we can use different type of IP address that works with our network. But if you leave the router, if the system, right, the send, transmit, past the router, it has to use a public IP address. And that public IP address is given to you by your service provider, right? Like, so when you get a smartphone, right, your smartphone has a public IP address that's given to you by T-Mobile, Verizon, AT&T, etc. And they have a list of IP address, right? Now, inside our network, we can design a certain type of IP address to be used. So when you look at an IP address, okay, we need to kind of break down what is going to be the network ID and what is going to be the host ID. So think of the network ID as in zip code to your house, right? When you're shipping a package, the post office rely on the zip code to get that package from where it was sending from to the post office where they are going to bring it to your house. So the network ID for the system, it's used to really navigate the traffic or bring the traffic to the area of the network, right? The segment of the network that is where that system resides. The host ID is used for the actual system. So each IP address will consist of network ID and host ID. One is to narrow down what part of the network that system belongs to. Two, the host ID is narrowing down which system is receiving or sending traffic. Okay, so it's very important to think about that, like a zip code and a home address. The network ID is unique to that system, so you cannot have a duplicate host ID, but you can have the same network ID because so all of these computers, let's say on the same segment, they have the same network ID, but each of them have individual host ID, okay? So let's go through and take a look, okay? So what they do is they use a number that's called a subnet mask. So the subnet mask is the zip code, okay? The subnet mask represents what area of the network, right, that it needs to narrow down to. So as you can see, this is a class C address, right? So how do I know if it's a class C address? If this number in the front, the first octet, is in a higher range, right? It will belong to a class C range, and that's going to tell us it's a class C address. You can also tell that it's a class C address by default by looking at the subnet mask, okay? So if you're looking at binary level, when all the bits are on, it's going to be 255 in decimal. We'll see this shortly. I will convert it. So if I have the first octet, the second octet, and the third octet on the subnet mask on, the system would know that it is going to be class C for one, and that's the part of the network that it needs to send to. It's kind of like, how the zip code is 92551, right? And I live in the other part of Moreno Valley, and I would have a different zip code, right? A higher number. So it would know what part of town, right, that system belongs to. So when you look at this subnet mask, the default class C address if all of these 3 bits, these 3 octets are on, right, that would represent your network ID. So simply the system just look at all the 24 bits. If it's on, it's gonna send it to that switch that's handling that part of the network, okay? It doesn't need to detect like which number, it simply look at which bits are on and which bits are off. So if the first 24 bits are on, it's going to send it to that direction of the switch that's handling that particular system. Okay, so when you look at the value, like I said, right, network ID, network ID, network ID, and the 0 is going to, that part of the zip code represents the host ID. So in this case, for the IP address 192.168.1.15, that 15 represent that individual system. That could be a laptop, that could be a workstation, right? That could be, you know, your smart TV. So now if I have another computer, that will be a .16, a .17, or it could be, you know, so it would be a different number at the end for the host ID. Okay, any question? Okay, so it uses the subnet mask like a zip code, right? And it uses the host ID to kind of find the individual house, right, on that street. Yes.
So the host ID, can it be infinite numbers or is there?
No, yeah, there's a limit, right? So if you're looking at the 8 bits, everything is on is 255. We don't use 255 because that's a broadcast value at the end of the range. So when it becomes 256, it leans into the next octet. So you only have, in this class, you only have 32 bits. So that last value right here, it can only reach 254. We don't use 0, we don't use 255. Those are broadcast values. So whenever that you see a .0 at the end, you know that that system is sending to all the systems. It's also 255 is also a broadcast value, right? So you do have system that communicates to all the system, like we talked about simplex and half duplex and all of that, right? So at home, when you're looking at your IP address, you can see that each of your system has individual host ID, but they have the same network ID, right? So if I have many systems on the network, if it's a class C by default, you're gonna have 192.168.1.15.16.17. So this value at the end changes. Okay. But we'll talk about subnet mask and how we can manipulate that when we're doing subnet in a couple of weeks, when we can tweak it a little bit, and so we can borrow into different octet down the line. So this is a default class C, which is used for small networks. Okay, so good question. That is there a limit, right? So that means that if I'm using class C IP address, I can only have up to 254 systems, right? And normally your router at home doesn't handle that many actually, right? So the more you add on, the more it's gonna slow down. So what you see is if you have a very small network, you can go with the default class C and you can have up to 254 systems. But if you have thousands of systems, you can use class B. And if you have millions of systems, you can, or hundred thousands of systems, you can use class A, which is what you see at RCCE. We'll talk about the classes shortly. Okay. Okay, so when you see, right, now what I can do is I can separate one system from the next system into a separate network by changing the network ID, right? You see this one is a .1 and this one is a .10. It's completely different network, right? So that represents different town, right? Different. So computer 2 can be on a different network if we modify the network ID, right? This is how we can separate it. But you said, wait a minute, how is it that it is .10 here and .1 here, and it's also 255? Well, by default, class C, right? These all three octets are going to be on. So what it does is it's going to narrow down because the router needs to take your traffic to the town, okay? And inside that town, we would have maybe multiple switches to handle. One is going to be, let's say we use this for VLAN. That switch is going to be handling this part of the network, and another switch is going to be handling that part of the network. So we'll talk about that when we do subnet. Okay, so it kind of give you a little bit of breakdown on what I just talked about. Okay, and like I said, right, if the computer looks at that value, this is what it sees, the 0 and 1. So we're going to do the conversion so you can see what the computer sees, or the switch or the router, what it sees. Okay. Okay, so in binary is a base 2 number system. Most of you kind of learned this if you have taken like a beginning class, right? The computer, because it's an integrated circuit system, it's either receiving signal that's going to be approximately 5 volts. Actually, yeah, so it's close to 3 volts. So it's going to peak, so it's going to receive electrical signal at close to that. And then it's going to drop to 0 when it turns off, right? And all your data, all your communication works this way. So when you're looking at a byte, right, which is an 8 bits, the right bit is going to be, has the least significant decimal value, okay? So this is called your LSB, your least significant bit. We are always going to start from the right going into the left. Think of it like if you're counting from 1 through 10. 1 is the lowest value, right? And that's going to be on the right side. Okay. Now on the left side, the 8th bit here is the most significant bit. And that's going to be the highest in the value. So if I'm looking at a byte, right, because this is the base 2, this is the first bit, the equivalent of the first bit in decimal is going to be 1. Because if you take 2 to the power of 0, that's going to be a 1. Okay? So exponentially, when we go from right to left, we would say 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and so on, because it's multiple by 2 is a base 2 number. Okay? So the first decimal equivalence for the first bit is always going to be 1, right? And I take 1, I multiply it by 2. The next bit, the decimal equivalence is going to be 2. And then the third bit, if I take 2 times 2, I get a 4. So the decimal equivalence for the third bit is going to be 4, if that's on, right? So if this is off, it's a 0. So if this is on, it's 1. If this is on, it's 2. This is off, it's going to be 0. But if it's on, it's going to be 4, right? And 8, 16, 32. So if you just start with a 1, you think, oh, I multiply this by 2 because it is a base 2. I take 1 times 2, I get a 2 times 2. And I would continue that all the way to the byte. Now, can you have something that goes into the next byte? Sure. You might have data that is very large, right? So like when you download, you talk about this, right? My file is 1.5 gigabyte, right? So simply it's chunking it down to all the 0 and 1s, and it's going to be in pieces of 8 bits, right? So this is what you see. So that's what we're gonna work on next. Let's go through and answer the next question. Okay, for number 2, we talked about this address, right? So determine the network ID for the following IP address in the subnet mask. So when you look at an IP address, first, you look at the first octet, right? And the first octet here is 192. So your mind should go to, and I'll show you the table, that's a class C address. So if it is the default class C where it's not, we're not changing the subnet mask, you're gonna have a default subnet mask of 255, 255, 255.0. This is like the zip code we talked about that. So that means that when the 3 octet for the subnet mask, if that's on, that represents your network, and host. Okay. So I will highlight. So this represents the network ID, right? And then the last number, the 100, represents that unique part of the IP address for that system. That's like your home address. That's different than the next house on the street. Okay. Now, the second IP address is a .10. And when it's a lower number like this, from 1 through, right, 127, that's a class A. So you have class A IP address, and class A IP address, only the first octet of the subnet mask it's on. Okay. And then class B is the next one, right? So you see that there's only 8 bits for the first part of the subnet mask is on, and that would represent your network ID, right? And then the rest is going to be host. So this last 3 octet on this IP address represents the host value. Now, let's say that this is my router, right? The next appliance is probably going to be your switch. So that will be 10.0.0.2, right? The next system, let's say that I have a server that will be 10.0.0.3, and so on, right? You always want to start the router with a .1 because that's a first system that you see when you are coming into a network. And then you would follow that. So logically, the next appliance, like let's say you have a firewall, that's a .2. The switch is going to be .3. Other switch is going to be 4, 5, 6, right? And then at the end, you might have like the .150 for maybe a workstation and so on. And we will work on DHCP down the line. Now, if I want to tweak this, if I want to have a different network, I can say 11 here, right? Because that's the network ID. And when you have different network number, you have to have a router or a layer 4 and up switch to handle that. Okay. So you have to route it. So once we have the network ID, it narrows down which network that is, right? So the routers is going to be looking at that, and that's how it passes traffic. The next IP address, this is a class B, right? So 128, right, 2191, I believe, that's going to be, so 172 is in that range, that's a class B. And so in class B, the first 2 octets for your subnet mask is on. So your network ID is going to be the 172 and the 1 here, 172.1. And that represents the network. Now, class B is mid-range, so if you want more systems than class C, you would use class B. It's not that popular with a lot of admin because if you're looking at enterprise network, you're going to see class A. A lot of admins, they like to use class A to start so you can grow with the network. So let's say that I have 50,000 systems, right, already to start. A lot of them, if they design that network, they normally start with class A because what if in the next 5 years I grew exponentially and I would have enough IP address to be able to handle that? You don't want to reconfigure everything when you're changing IP address, so you have to think about the IP address numbers of the newer system that you're going to add when you're designing a network. right? So that's important. If you're aspiring to be a network engineer or a network admin, usually you have to think about like how you can scale, right? 5, 10, 15 years and not having to reconfigure a lot of things. Okay, now D is tricky, right? I will teach you how to subnet down the line. Okay, you said, wait a minute, this is a 10, that's a lower number that belongs to class A, right? In some cases, what you see is we can use subnetting where we can tweak the subnet mask so that way we can borrow into different class, right? Remember that this is a class A by default right here. But what if I ran out of IP address, or what if I want to design it where I can have a lot more IP address, I can borrow into the next object. So in this case, when you look at this number, right? So you have a 10, but the subnet mask here is going to give you away. So this is a network ID. This is also a network ID. So it is not a true class A. It's not a default class A IP address. It is a subnetted, right? Class B IP address. So your network ID is the first two right here. And how do I know that? By looking at the subnet mask. I can't use 255 here because that will be default class B. So when you subnet mask, you have to borrow a bit. So that's going to be 254. We'll come back to that in a couple of weeks. Okay. So again, right? Subnet mask usually is looked at by the router or a higher layer switch to determine which part of the network this system belongs to. Okay. And then the switch would then look at your host ID to determine which system that is on that segment of the network. It usually look at the MAC address though, but on the switch table, you also see, like for the R, you also see IP correlated with that. So I'm gonna let you know, right? Network Plus, they don't really emphasize a lot on IP subnetting. But for practice, in security or IT, you have to know these things, because when you're scanning system, you're gonna see IP addresses. And sometimes you have to logically think about like, oh, is this group of IP address belong to this part of the segment? If you're doing ethical hacking, sometimes you have to kind of dive deeper on where that system is, right? Where the servers are, or security appliances where they're placed logically. So you have to kind of know and understand IP address. And it is a harder concept to grasp because, they built this with a logical sense, right? Okay. So we talked about network ID and host ID. And when we do subnetting, we're going to come back to this. And then for the third question, it says, if computer A is sending data to computer B, how does the computer A locate computer B in the network? Right? And we're only looking at inside the network. So the computer A, right, this first system is going to look at the subnet mask of the destination where that's sending to. It's like how you are sending a package to your friend, right? The zip code is going to be determined what town that package is going to go to. So the post office is going to look at the zip codes. So the system, the way that it handles the traffic is going to look at the subnet mask, which is the zip code. Now, if the computer B is on the same network, right, it checks the network ID. Like how many bits are on, how many bits are off, and that's it. Okay. So it looks at the value that you see with the network ID. Okay, So for 4, it says to send data in the same network, what configuration is needed on the sending and the receiving system? So we will work on this down the line. You saw a little bit of network adapter configuration. You took a screenshot of the IP address and the MAC, right? We are going to go in and we're going to statically give the system an IP address. That means that we manually enter an IP address for that system. And you see this with server system, right? Maybe a dedicated printer, a copier, security appliance. So the way that we look at this is if it's using IP, because we talked about TCP IP, it's going to find the system IP information of the system, right? And it's going to look at the subnet mask. So you always going to have an IP address and a subnet mask go together. You cannot have them separate. The subnet mask is really determined, right, whether it's on the same network or not, right? And the actual host ID on the IP address is going to tell you which system. So it doesn't matter if you're using Linux, if you're using Mac OS, if you're using Windows system, right? You're always going to have these values. And the world systems are made of, they have these configured. So now, if you are leaving your network, if you're going past your router, let's say that you're visiting a website, right? The traffic is then going to be routed to the web domains that you're visiting, like youtube.com. Well, how does the system know where to send that to? It's going to look at the IP address. Well, DNS is a way that we can correlate the domain name with an IP address that's publicly given, right? For example, google.com is like 8.8.8.8, but Google owns a lot, right? So they have many web servers and many DNS to handle all the traffic. So it's going to look at the domain that's associated with the IP address if you're visiting a website. And then based on that, it's going to examine the subnet mask to say that, oh, now I got to take it from this network into the next network or the destination network. So the subnet mask is going to tell it whether it's on the same network or not. So it has to leave the network. And then also the default gateway, which is your router, mostly, right? So that means that it has to exit, right, the network through that gateway. Okay. So that's when you have system that is communicating with external network systems. You have any question? So the difference between inside your network and outside your network, it has to also look at your default gateway, which is your router. Okay. And this happens all the time for us, right? Like I know that if you're gaming, if you're downloading, if you're visiting a website to access something. All right, let me take 4 and 5 down in case you're still working on those. And let's bring this up. Okay, so now we're gonna do the conversion. So my point of doing this is to make sure you understand what the system sees. Okay, like I mentioned before, the binary, the value that you see in an IP address for version 4 is in decimal. That's the human counting number, 1 through 10, right? That's a base 10 number. Now, the computer uses multiple number systems, right? We talked about the MAC address last time, and that's a hexadecimal number. It's a base 16. And then today we're gonna look at the binary number, which is 0 and 1s, and that's a base 2, right? So those are the predominantly the 3 along with the octal number. Octal numbers are for older computers. We rarely use octal numbers anymore, and that's a base 8, right? Okay, So let's say that this is like the first octet of my IP address, the 172, right? Let's see what the computer sees as binary. So when you do the conversion for the base 10 number into a base 2 number, there's two techniques. One is subtraction, another way is division. Right? When I teach assembly, I tell them that when you divide, you simply subtract multiple times, right? So, and that's mathematically, that's the logic, right? So I always start with subtraction because it's easier for people. So you are going to always have the multiple of 2 scale because binary is base 2. Okay? And you're always going to have 8 bits in a byte. Okay? Remember what I said, this scale stays the same for the equivalents in decimal. So the first bit on the right side, the least significant bit, if that bit is on, it's always going to be equivalent to decimal 1, the number 1 that you count. Okay? Now, when you are going from decimal to binary, you would take the given value, the 172, and you would subtract the value that's at the most significant bit, which is 128. How do I know it's 128? You take 1 times 2, you get a 2, times 2, you get a 4, times 2, you get an 8. And you continue that until the 8th bit takes 64 times 2, you get a 128. So the decimal equivalent on the 8th bit is 128. So I take the 172, I subtract the highest value, which is 128, I get a 44 as a remainder. Okay. So if you can subtract that value, that bit is on. You put a 1 for that bit. Okay. Now 44 is less than 64. I cannot subtract the 64, that bit is off. You put a 0. So simply the technique is you look at the equivalence decimal scale, which is multiple of 2, you find the highest value on that scale and you subtract it. Okay? And then you get a remainder. We're not done. So if you can subtract it, you put a 1, that bit is on. You take the remainder, which is 44 now. You look at the next number, is it higher or lower, right? It's lower, so you cannot subtract it, you put a 0. Then you go to the next number, the next bit, the 6th bit, it's a 32 equivalents in decimal, so I can subtract 44 to 32, right? So 44 subtract 32, you get a 12. If you can subtract it, you put a 1. Okay? And then I have, after I subtract 32, I have a 12 remainder. I looked at the next bit, the 5th bit, the equivalence is 16. It's too large, so that's off. You put a 0. If it's less than the equivalence in the next bit, you cannot subtract, you put a 0. Okay? And then I take the 12 and I go down to the next bit because I cannot subtract 16. So I put a 0 there. I look at the value in equivalence. That's an 8. So 12, yes, I can minus 8. So 12 subtract 8, right? I have a 4 left. So if I can subtract it, I put a 1. And then I have a remainder 4. I continue. Can I subtract the next equivalent bit? Yes. 4 subtract 4. So you go until you get a 0, right? So 4 minus 4, I get a 0. So I subtract it. So I put a 1 there. And then since I have a 0, the last, I can't subtract anymore, right? The last 2 bits, I place 0 there. So a 172 in an IP address, the computer is going to see it as 10101100. And you see this on the router, you see this on the PC. So this is the equivalence. Now, this has to be happening instantaneously, right? Like you can't, like unlike the human, the computer, it quickly converts this, right? Because everything it processes is in binary. So did you know that in 1945, the computer was really created for calculation, arithmetic calculation, right? So based on von Neumann model, the computer itself was created to do arithmetic, multiplication, subtraction. And at the low level, you see all of this, right? I'm going to tell you the secret. Computer only adds, okay? You're like, why? How can I get negative numbers? Well, that's what we call a sign number. So if you subtract, you simply add the sign number. And if you learn low-level programming, you actually see this. So this is what we see as the binary equivalent. Okay? So that's one. Do you have any questions? I know this is new. It takes a little bit of practice. Now, you can use a calculator to check on your Windows PC, and also Mac OS has a programmer calculator too, same thing with Linux. If you open up your calculator, right, at the top, if you click the 4 lines or the 3 lines menu option, you have different mode for your calculator. Did you know that you can use it to convert currency and other things, right? Some of you knew that. Like you can look at like metrics and inches and all of that. So if you open up your calculator, if you select the programmer calculator, you would be able to check your calculation. Okay. Now, let's say that I start with the decimal value. So click decimal, type in 172, and then click bin for binary, and that's what you have, right? So does that match my answer? Yes, it does, right? Now see how it chunks it up into 4 bits and 4 bits, and you might have learned this in 25 or CIS1A, that's called a nibble, right? And that's a 4-bit, so 4 and 4. So ultimately it gives you a byte, and that's the equivalent to what we have manually. So how do I enter this? I simply, so let me clear it. You click DEC for decimal. You type in 172, and then you click bin, and you have your result. And that's a programmer mode on the calculator. And you can see there's octal, there's hexadecimal, right? Your MAC address, and memory addresses also are in hexadecimal. And we'll talk about IPv6, it is hexadecimal. That's down the line. Any question? Okay, so let's do the next one. So earlier we saw that 255 was on the subnet mask, and I wanted to show you what that is like, right? On the scale. So let's not look at the answer here first. So if I take 255, remember what I said, you go look at the scale from 1, right? The first bit all the way to the 8th bit. You ask yourself, what's the highest value I can subtract from? So I would take the 255. I said, oh, I can subtract 128 from it. So I would then do that. And if you subtract, you put a 1, right? So I take 255, subtract 128. I have a remainder of 127. So as you subtract it, you place a 1 underneath. So that 8th bit is on. Then I take the remainder after the subtraction. I ask myself, can I take that remainder and subtract the next equivalent value for the next bit, which is the 7th bit, and the equivalent is 64. So if I take 127, subtract 64, right? I have a 63 left. As I subtract, I place a 1 there. And you would continue to do that from the 8th bit down to the last bit, which is your least significant bit. So I take 63 as a remainder and I do that again, right? I take 63, I subtract the 32, and I have a 31 left. So as I subtract, I place a 1. And then I ask myself, well, 31, can I subtract 16 from it? Sure. So 31 subtract 16, which is the next bit, that's a 1. I put a 1 there because I subtracted it, and I have a remainder of 15. 15 is larger than 8, so yes, I can subtract the next value. So 16 minus 8, I have 1. I put a 1 here because I subtracted it. So I have a remainder of 7. And then 7, is it larger than the next value in the scale? Sure, right? 7, I can subtract 4 from it. So as I subtract, I place a 1. And 7 minus 4, you have a 3. Remainder. And I keep going until I reach 0. So 3, can I subtract the next value? Sure, right? So the next value in the scale is 2. So 3 minus 2, I have a 1 remainder. So as I subtract the 2, I place a 1. So that bit is on. And then lastly, I have a 1 remainder. I have to keep going until I have nothing left. So 1, can I subtract the next value? Yes. As I do that, I place a 1 and I have nothing after I subtract 1 from it. So when you look at 255, all the bits are on, right? If you have 254, this last bit is off. All right. So understanding this is gonna kind of give you a better understanding of what the system's seeing. So it's just when it sees if all the bits are on for that octet, right? That's 255 decimal equivalent, all the ones, right? All the binary values equivalent. And let's check with your calculator. So if you want to go back to your calculator here, right? I can clear this. I select decimal and I can type in 255 decimal value and my binary is all ones. So I did it correctly. Pretty easy. So I'm not going to make you do addition or subtraction or multiplication, division with binary, but the programming classes, they have to know how to do that. But yeah. So it's supposed to, everything that we're giving you, eventually it's going to gel together, right? And understanding the low level of your system is important because we kind of have to see like what it's seeing, how it's seeing this. Any question on number 7? So you can practice, right? Maybe for the quiz, you should be able to do that. And of course they make calculator for a reason, so that way it's convenient. Will all the administrator manually do this? No, right? I want you to understand the concept so that way it makes sense when you look at values. Okay, so in the notes, right, I explain all the process. Now we're gonna do in reverse where we're gonna go from binary to decimal, right? How it converts the binary value and give you the decimal that you see. So we're gonna do addition, where if you're going from decimal to binary, you subtract. If you go the other way, binary to decimal, you add. Okay, so now let's do 127. When do I see 127? Well, that's in the loopback address, right? We talked about how we can ping a loopback address. So 127.0.0.0.1, right? So that 127 value, can I convert that to binary? And you can practice. So here's my solution, right? The scale stays the same, 1, 2, 4, 8, 16, 32, 64, 128. That doesn't change because it is 2 to the power of n, or a multiple of 2. It is a base 2 number of the binaries. So you take the 127, you ask yourself, can I subtract the 8th bit by equivalence? No. 127 is smaller, so you put a 0, you cannot subtract it. Okay. Then I go down to the next bit. I would take 127. I can subtract 64 from it, so I place a 1. 127 minus 64, I'm left with 63. And then I would continue to do so. So 63, which is the remainder. I go down to the next bit. Can I subtract 32 from it? Yes, put a 1 if you do. So 63 minus 32, you get a 31 remainder. Take 31, compare that to the next bit. Can I subtract 16 from it? Yes, put a 1. So 31 minus 16, you're left with 15. And you would keep going. So the next bit, 15 minus 8, yes. So put a 1. So 15 subtract 8, you have a 7 remainder. And then I take a 7, I check the next bit, which is a 4. So 7 minus 4, I'm left with a 3. So if actually subtract 4, you put a 1. And then the 3, you would continue until you get a 0. So I subtract the next bit, which is 2. And I'm left with a 1. And then 1 subtract the last bit equivalent, which is a 1. I'm left with a 0. So as you can see, 127, the absence bit is the 8th bit. Okay. As 255, right? All the bits are on 254. The absence bit is the least significant bit. And so you start to see a little bit of a pattern when you look at this. And integrated systems, it's just looking for signal, right? What's on, what's off. Okay, any question regarding decimal to binary? Right, we subtract. Now the division method, you just take the value divided by 2, you divide it by 2, you just put a 1, and you go from bottom up. And I don't know if I think I put that on your notes also. Okay, so now we're gonna go in reverse. We're gonna take this binary value and we're gonna make it into a decimal, right? A base 2 into a base 10. So as we go from decimal to binary, we subtract. When we go from binary to decimal, we're gonna add. Okay, so what you do is you use the same scale, right? 1, 2, 4, 8, 16, 32, 64, 128. That scale remains the same for decimal equivalents to binary, no matter what. Then what you're going to do is you are going to place the binary value, each bit under each of the equivalence value on that scale. Okay, so I would take the first bit here, which is a 0. I put the 0 there. The next 0, I put the next 0 there, and so on. So you place each bit under each of the equivalence value, right? Because that's bit 1 through bit 8. Now you notice that I highlight the equivalence value that has the 1s underneath. Those are the value that you're going to add up. Okay, because these bits are on. Okay, So as you look, the 4th, the 5th, the 6th, the 7th, and the 8th bits are on. So we're gonna take the equivalence value in that scale for the on bits, and we're gonna add them together. So I can start with the 8, or I can start in the front. That's up to you. In my demonstration here, I take the 128, right? That's the bit that's on, the 8th bit. I add it to the next bit, which is also on. 64, I add it to 32. I add it to 16. I add it to the 8, which is the 4th bit. And I don't add the last 3 because it's off, right? Those turn off. We don't care about those. So once you do your addition, you have 248 to the base 10. Now, if you want to type this into Word, right? You can use the little symbol underneath the font, the X with the 2, and then you can put in the lowercase if you want. But so people denote binary as in 0 and 1s. Technically, we need to put a base 2, right? But when you see binary like this, you already know it's a base 2. But numerical value like a decimal or hexadecimal, if you want to indicate it's a base 10, you gotta put the base number, right? So I added everything up. I have 248, and that's a decimal value. And you can check, right? You can input the binary into your calculator, or you can do in reverse. So if I take decimal 248 and I check my binary, it's exactly the same as the question. So I got the right answer. So if you want to input binary first, you simply press clear, click bin, and it only gives you the 1 and the 0 here. So you just type in, right, 1, 2, 3, 4, 5, and then 1, 2, 3, 0. And you click the decimal and you have the answer. And it gets easier as you go, right? So for the next question, we're going to take this binary value, right? And we place it under the scale. 2, 4, 8, 16. We place each value under each of the equivalents for each bit. And we're going to only add the equivalence value for the on bit. So 1, 2, 4. So that's going to give you 7. And then the 11 is really easy. You have the 8 bit and the 1 bit that's on, right? So 128 plus 1, 129. So as you become more familiar with the scale, if you know the placement of the bits and the equivalence value, it's quickly, you can quickly solve it. So if we convert this binary value into a decimal, again, we place it onto the scale. We look at the bits that are on, and we add the equivalence value of that bit. 128 plus 1, which gives you 129. Okay, question? So that's probably like the most math for math. In IT and cybersecurity, right? You don't, like statistic is important to learn. I probably applied calculus theory for like maybe a few of my advanced classes in my master's and doctorate programs, but ultimately, like this is probably like the most important math that you kind of know, and then the subnetting piece. Yeah. right? So if you can do subtraction and addition, you're pretty good. So don't worry about the rest, right? So, but understanding, right, there's different number systems, the equivalents of it. I don't teach it with exponents because sometimes that can be hard for the student. I always like to do subtraction and addition, so that way it's really easy. Everybody can probably get through some of the basic math. Okay. All right. Any question regarding these exercises? Okay, so there's also example, right? And I put there's some illustration of what we have just done. And I put down the steps. So if you want to go back and review and do some of the example in the notes, you can. I didn't put some of the other techniques on there because based on my past experience, sometimes that confuse students. So we just stick with the subtraction and the addition. But if you're interested, right, I teach 7 and 11, and that's the first two things that they do is to do binary and hexadecimal conversion. You can also watch those videos. I demonstrate how to do that for those classes. Okay. Let's talk about classes, right? I touched on this a little bit earlier. So when you're looking at an IP address, okay, like for example, if you're looking at this IP address, it's really important that you look at the first octet. This octet, as long as it starts with in this range, then you know it's class A. So if I have 127, I know that it is a class A, right? If I have a 10 dot XXX, so the first value in the octet, that's the first piece right here before the dot. If it's in the range of 1 to 126, you know it's a default class A. Now we'll talk about subnet later. Don't worry about that now. And the default subnet mask, the first octet here is always on. The rest is off. Okay? Class B, the 172, like what we looked at, is in this range. So it's between 127 and 191. So this is a class B. And class B, the first two octet of your subnet mask is on. 255, 2550. So this represents your network ID. Network host, right? Whereas the other one, only the first octet is the network. And then your home IP, which is 192, right? 192.xxx, that's a class C by default. And class C goes all the way to 223. You often see in this industry, they use specific numbers, right? Can you come up with your own IP, right? Like for example, they would use 172 or 176 in class B. Most administrators use that. Some would use 179, but you would see that they would stick with a certain number so that way it's easier, or 10 in the class A. You rarely see like a dot 12 dot whatever, or 15 dot, right? So it's just the way that we were taught, and schematically we just do it so that way, you know, if you go to a different network, you're able to handle that. Can you use your own unique number in that range? Sure. You know, but by practice, I think they just pick a certain number to use commonly. And then class D and E, we do not assign IP addresses in this area. This is reserved for multicast groups. So when we say multicast, is like if I'm sending to a group of systems, okay? In a network, I might have a group of servers, I might have a group of switches. So these IP addresses are used for multicast purposes. It's not broadcast. Broadcast is to all the system. Multicast is to specific groups. Now, class E is specifically used for research purposes. We don't touch those. So these two off the list, okay? So if you are designing a network, you would try to stick with the first three classes depending on how many systems you need. So if I have a lot of computers, right? Exponentially, I can have this many computers. So if you take 2 to the power of 24, right? Because these are the host values, you see? So that's 24 bits, 2 to the power of 24. I have that many computers I can accommodate. Whereas class B, I have less, right? 2 to the power of 16. I can have that many systems and this many networks. So if you have more networks, more networks and less system in each network, you would go with the later class, the B or the C, right? The C is the smallest number of system on the network, but you can have many networks. Okay. Question? Okay. So let's answer the next few questions. I'll take 11 to the next page. Okay. Okay. So for number 12, right, you're given the IP 10.0.0.101 with the subnet mask 255.0.0.0. So like I said, it's important to look at the first octet, right? And the first octet of your subnet mask. So the first octet of the IP and the first octet of the subnet mask, right? And C. Or any, so this one, it is a class A. How do I know it's a class A? It's between 1 and 126. 10 is in that range, right? And the subnet mask for A by default is 255.0.0.0. So I know it's a class A address. So and this is important before you subnet, you have to think about the IP address, the default class of your IP address to start with. This is why I'm covering this now, because a few weeks from now, you're going to subnet and you have to know where you start. So if I start with this IP address and the default subnet mask, I start with a class A, right? And I can tweak the subnet mask to lean into class B if I need to, but I have to ask myself, what class is that IP address? So now I know that when you did your topology, right, you go home and you might put down your IP address or you might look it up. So if you do IP config on your Windows PC at home, you might get an IP address. So I'm going to use this as an example. So this isn't one of the IP address that I pull, right, from a system at home. So 192.168.0.23. And this is a class C address. Why? Because the first octet, the 192 here, is in the range for class C. So going back real quick, I know that you were typing, right? 192, right, to 223. So it belongs to class C, and this is the default subnet mask for class C. Okay? So when they created that class, they specify that this is the subnet mask, the zip code that we're going to use. So it's a class C, and that's the subnet mask. Now on your school computer, let's find that real quick. Right? So here's my IP address. You see how this is not a default class A. You see that? 10 is a class A. But look at the subnet mask, right? It's 255, 255, 224. They subnetted. So it leans into other classes instead of using a default. Why? Because maybe they just have a lot of systems. Or maybe they want to design it with the subnet. So you do see subnet. So when you look at this, you already know that they created subnets for the IP, right? So I put down something similar. So if you're looking at 10.111.90.11 or any other value, right? If I'm doing a subnet non-default subnet mask 255 to 224 like that, it is technically a class C, right? But it is a subnetted IP address. So they had tweaked this to use other class for the IP. So it's important to look at the subnet mask as well, in addition to your first octet, because if they subnet it, you can see that the subnet mask. Okay. Then the next question, you have 172. And then you're looking at the subnet mask here, 255. Going back to the notes, you would see that if I have 172, right? 172 belongs to this range, 128 to 191. And the subnet mask for that is 255. So that match up. And 14 is a class B. And then 15, we know that D is for multicast group and class E is reserved for research. So we don't use any IP in that range unless that's what you do for a living. We set up multicast groups and to research. So if you're looking at, like, they might have, to use a certain IP address for testing system or researching system, they would refer to class E IP addresses for those. So technically those don't get given, they're not given to the public IP range for general use. Okay, so the takeaway from this section, right after the binary conversion, is to be able to determine which class is your IPv4 IP address, right? By looking at the octet and the subnet mask. And then understanding the range of your classes, right? Remembering those is important. That might come up on certification. If you go for CCNA with Cisco, you definitely need to know your IP addresses and your subnet mask and subnet. Right, Cisco is known to test you on those. Because when you're programming Cisco switches and routers, you have to make sure that your systems and your devices are in the right networks and the right subnets. Okay, so let's go through and determine which one is valid and which one is not valid, right? Okay, so for 16, I have given you a bunch of different IP addresses, and we have to determine which one is usable, okay? Now, if you're looking at 16A, 192, 168, and you see the last two as .0, we don't use 0 for individual unique system, okay? Not for a whole system, because 0 is used as a network address, okay? Routers use the zeros to determine, right, what part of the network it needs to navigate to, right? So for A, because this is it could be a default class C address, but if you look at the host ID, if it is a 0, you know that this is a network address. We don't use that. Next, B. You look at the address, you said, oh, 10 is a class A. But if you look at the host ID, it's a 255. If this thing is off, it's a network address. For the host octet for 255, if all the bits are on for the host ID, it's a broadcast address. It sends to everybody. So we don't use the .0 for the host ID at the end, this one. Okay. And the 255. That's just the rule. 127, you know that this is dedicated for the system to see itself, right? To find itself. So this is a loopback address, 127.0.0.1. We don't assign that to any other system, right? This is used by the network adapter as a loopback address to see itself on the network. So cannot be assigned. Loopback address. Then when you look at D, 172.0.1.1, the unique ID here, yeah, that works, right? So this is a class B address. And if you look at the host ID, 1 is a unique. It's not 0, it's not 255, it's not the beginning or the end of the range in that. So this likely is a router, but it can be assigned to a system or a gateway. Then you look at the next address, 216, right? That's a valid range. It's not in D or E. So, and then your host ID is 103. That's okay. It's between 0 and 255. So it can be used for a system. So let's say that I can use this for a workstation or some system that's connected to my network endpoints. And then F, because of the octet in the front here, right? You look at the class. This is in class D, so you cannot use this address. It's for multicast. The same thing with G. You look at the first octet and look at your class. And 246 is in class E, so you cannot use this address. It is for research. And then lastly, when you look at H, 182.3.116.7, yes, this is in a valid range. It's not in D or E, the first octet, and the host ID, the last octet, it is unique. It's not 0 or 255, so it can be used. So you look at your first octet and you look at your last octet, okay? So the takeaway from this, when you do this, right, ask yourself, is the host ID 0 or 255? If it's not, right, check your network octet, the first octet, and see if it is in class A, B, or C. And you're good. You will see some questions like this on quiz and final exam. So make sure you can understand how to determine valid IPv4 from invalid IPv4. Easy, right? Okay. Again, the classes, you can find this on page 4 of your notes, right? And then I gave you some example, like Google IP is this, right? And the first octet, we would see what class that is, how you can determine the class, what's a loopback address, and then illegal IP addresses, right? We do not use 256, that just surpasses the 255, that's beyond your 8 bits, right? And then the 0 for network ID and the broadcast ID for the host, you don't want that. You don't want to use, those are non-usable for endpoint system or host systems. Okay, and private and public IP address is about the bottom of 5 going into 6. So for the private IP address, that can be used inside your LAN, your local area network. Now, leaving the router, your traffic takes on public IP address. It's kind of like inside your house, they can call you all kinds of nicknames, right? But the world sees you as your legal name. Okay? So the router, what it does is it does network address translation for all your systems. You only have one public IP for your home system, right? For that router. So when you subscribe to a service, they give you one public IP, and your router, it takes all the traffic from your inside your home network and it converts that and it sends that out, right? The source is only going to, that router is used, identified with that one public IP. The world sees it with that one public IP. But inside your home, you have the 192.168.xxx. You can have many, right? So in a network, that's what you see. You see that it resolved to the public IP address from the private through that router. Okay. Now, security standpoint, right? There are many ways to capitalize on that from an attacker standpoint. So we want to be able to kind of see what the attacker also sees. So if they match your public IP, right? They use your public IP, they take on your identification. It's like how sometimes people take your social security number and use it, right? So they can and take the system and make it into your system so the world can see it as your system, right? So public IP is used for the world, where private IP is used internally inside your network. And you can come up with any schematic that will be suitable for your network environment inside, but leaving your router, it has to be assigned with the public IP. So network address translation protocol, your NAT, right? And next time when you turn on your virtual machine, right, look at your NAT setting. So what it does is whatever the traffic that's inside your virtual machine, it translates that to your host machine, right? And it sends it through the network. That's how you get internet on your virtual machine. Okay. Another thing I want to point out, this is called APIPA, APIPA. This is a default address that's given to all network adapter. So whenever you see the 169, that's not a real address on the network, right? That's just something that the system has to start with. It's not like if it's 169 offset right here, you know that it's a APIPA address. It's not assigned by that network. Okay. Now, because you have to have something there to start. It's not a usable address in a private address that's usable on the network. So if you do IP config and it shows up 169, you already know that that system needs to be rebooted, right? And the network adapter needs to check so that way you can verify that it is connected to the domain or the network to get an IP address that's legitimate for that network. Okay, so the difference between your private and your public IP, one, private IP is not routable. It doesn't leave your network. It's inside, right? The world doesn't see it. It's used for local area network only. And if you want to route it, you have to put it through NAT, Network Address Translation NAT. So you have to have a system, a server, that's going to handle that. So what it does is it's going to take all the inside private IP, right? And convert that into the public IP to send out. So at home, you do this. You can have smart TV, PC, laptops, etc., Android, iOS system, all of that leaving your network, and the world's gonna see only your given public IP from your internet service provider. The public IP addresses are routable, right? Externally to other networks, to your service provider. So they're given by your internet service provider, that's ISP. It can be used for wide area network. And so you need to have a public IP to connect to the internet. And then I want to touch back on multicast and broadcast because, right, we kind of defined that throughout like this session and also previous session. A broadcast is a process where you send data to all systems on the network, whereas multicast is a process that you send data to selected a group of systems on the network. So when you have a broadcast or a broadcast storm, sometimes they would say broadcast storm like on your switches. That means that likely that your network might have some kind of flood where multiple switches or switch sending to everybody, right? And that takes up your bandwidth. So broadcast would consume more network bandwidth compared to multicast. Because multicast, we can focus on a group of systems, where broadcast, we can just launch that out to everybody. Sometimes you need to broadcast, right? So a form of broadcast, that's what you see with wireless router, right? Wireless router always advertise itself. Here's my SSID, connect to me, right? Doesn't matter whether you are a wireless device on that network or not, right? Now you can stop the beaconing by configuring it so that way it doesn't advertise itself to everybody. But that is a form of broadcast. It's always gonna tell everybody what it is or who it is or what is its SSID. So now we know the difference. Make sure we know the difference between broadcast and multicast. Okay. So now we want to come back to the IP addresses that would be broadcasting, right? We saw this before. So based on this list, which one is the broadcast IP? Anything that ends with the 255 or at the end of the range. So you often see 255 at the end right here. So you're gonna ask yourself, the host ID, is it 255? Right? If it is 255, that's a broadcast IP. Now, if it's a 0, that's a network ID, right? So you don't, so broadcast is 255. Now, there's some exception when they use subnet. If it's at the end of the range, it's also a broadcast. So you have to look at the subnet mask as well. But in general, you see 255 is used for broadcast. This last octet right here, that's a broadcast system. Now, if I have 252 here, that's a legitimate usable IP, right? But if it's a 255 at the end, that's a broadcast IP. Okay, so there's the section, it talks about unicast, broadcast, and multicast. Right, unicast, it only sends to one system, broadcast to all systems, and multicast to a group of systems. And then virtual IP, you see virtual IP, you saw this when you look at your network adapter last week, right? It can be used for non-physical systems, etc. Okay, so let's talk about ports. I think we talked about this when we go over the protocols and the ports in the past, but we're going to come back to this. So ports are connection point. It could be physical port, like where you plug in the cable on the switch, right? Where you plug in your adapter, or it could also be a logical port, but simply to kind of have a parallel in that, ports are just windows or doors to the system. It's a way that the system can communicate for different services. So there are well-known ports, are also known as common ports, like when we talked about how port 80, number 80 is an HTTP port, right? So the industry have a list of the common ports, and each of the value is associated with specific type of services for the system, like web or mail, right? Like 53 is for DNS, right? And then you have the register ports. These are pertaining to application and protocol. So some of the common ports or the well-known ports are registered for specific services. And this is what you see, right? And we follow that, we use that. This is important for network, IT, and security in that when you're looking at, for example, when I'm looking at vulnerabilities on my system, I looked at what ports is used for what type of service. For example, if I use Telnet, right? Telnet has problems, and Telnet for the application it's not good. It's not secure, right? Everything is in plain text. So it will tell you the port number. And so the register ports, they have registered many ports for different types of service, and it's in this range, right? And then you have a dynamic port where it would temporarily use a value, right, for the time that it needs for the application to run. And then once it's done, it's going to give it back to the pool, and it's going to pick up another value the next time it runs something else. So dynamic port is not permanent. It is not statically registered. It's just something that's temporarily used for a certain service. So sometimes you see this. You see that the system is configured to use a value for the port for the time being, and that's it, right? So I put a link for some common port lists, but make sure that you are familiar with the common or the well-known ports that are registered for the service, like for HTTP, HTTPS, right? We talked about that in the prior weeks. Okay, so to answer that question for 29, why are dynamic ports used in the network? So that way application can use available ports to run the service. And it's temporary to execute certain tasks for communication or to complete a certain required task related to the service. Now, ports is different than a socket. So a socket is really an endpoint communication made of three things: an IP address, a port number, and protocol. So a socket would only exist if those three components are there. Okay? So a port is not a socket. A socket can consist of a port, an IP, and protocol. Because sometimes I see people loosely use them the same. They are not the same, right? And you can find that in the next section of the notes where we left off just now. Any question? So I think it's beneficial to really understand if you have a really good, strong foundation in networking, it really relates to the security concept that you learn in 27 or other classes, right? The lack in networking is you're gonna see that there's deficiency in how you will be able to interpret or analyze your security results. So I would encourage you to be more comfortable with this terminology and understand how things communicate, how systems communicate and set up for communication. It's important because 90% of the things that we looked at in security are network systems. So, okay. Let's switch over. So socket information is here, right? And then we'll come back to this where we would assign a static IP down the line. So you would know how to do that, but it gives you the steps on how to do that. Keep in mind that when you interview for apprenticeship or jobs that's related to networking, they like to ask these questions. And also certifications, you have to have those practice questions. So we want to be able to do that. Okay. Dynamic host control protocol, the DHCP, this is a function of the server to be able to lease or give out IP addresses that will be in the pool. I will help you set up a DHCP server down the line using your virtual machine. So leaving this class, you should know how to do DNS, DHCP, Active Directory, and all the other stuff, right? Some of my former students, they found it really useful because they ended up doing that in their internship or their apprenticeship part of the program. But DHCP server, its job is to give out IP addresses to connected systems on the network. We do this so that way we can maximize the number of IP addresses we use. So if I'm at a workstation and I go on a 2-week vacation, right, I can release my IP addresses for other systems to use. And we do that so we can have more IP addresses. So we would use that. Now your router at home does this. You can check, right? So that's how you're able to get the 192 addresses for newer systems that you connect to or when you refresh the system. Like for example, I use my Wi-Fi printer. I don't like to use it a lot. So whenever I'm not using, I turn it off, right? So it would be a .7 mostly, right? And then when I turn it off and I don't use it for a long time, when I reboot my printer to print, it would be like .11 or .18 or something. So it just pulls the IP addresses that's available, right? And be able to use it. So the DHCP, its job is to have that pool maintained and assign it to the system. There's because it's TCP, there's a 4-way communication similar to what you see with most of the other servers. We'll come back to this. Okay, so you have a scope, you have a pool of IP addresses, you would state the subnet mask that you want to use, right? And the default gateway, all of those things in your configuration. Okay, as you proceed down to the notes, it's going to talk about different rules for the servers again. We want to touch on BootTP a little bit, right? You see BootTP with router systems. And BootTP is important in network in that it needs it so that way it can set up usable IP addresses for the system that needs routing. For example, I work remotely from home, maybe as, let's say, a technician or an engineer, right? And I would connect to the domain once I authenticate successfully and get through the network through the remote server. My system would then be acquired with an internal private IP address. This is the way that we set it up so we can manage who's on our network coming in from external networks, right? So ultimately, BootTP is used so that way your requests for IP addresses, right, can be passed into different part of the network. So I would be able to obtain an IP addresses maybe on a VLAN or an IP addresses on, you know, a segment where my department system would have, right? So that's important. So when we get to the routing section, right, think about that when you are looking at BootTP. And then DNS handles fully qualified domain name. You often see the acronym as FQDN. Right, I mentioned before, human likes text, right, like google.com, that is associated with an IP address for Google server domains. Okay, so it is a way that we use the record on the system. The A record associates IP version 4 with the domain name. Google.com is equivalent to 8.8.8.8, for example. And so when you set up the DNS, you would set up a forward lookup where it would look up that IP address and the fully qualified domain name and then the IP address. Now the reverse lookup is where we can associate the IP to the name, right? The name to the IP is the forward, the reverse is the IP to the name. You rarely, yeah.
I was gonna say something about BootTP. Is that like part of the network adapter or is it both?
It is a service of the protocol. Yeah. And all routing systems have that set up, but you would only use it if you set up DHCP for routing purposes.
So any older network adapters, if they have BootTP,
No, yeah. So before TCP IP, no, right? Oh, yeah. So subsequent with the implementation of TCP IP, yes. But you would only integrate this if you are routing traffic and assigning IP addresses for specific system that you route. Some multi-layer switches, you set up DHCP for it, like for VLAN purposes, or routers. Like I said, it's commonly used like for remote access purposes, or you want some traffic from the inside, like people log in and you want to treat it like a private IP addresses. Yeah, you would set that up. And then so where can you find this information? We're coming to the end, so it's right. Your BootTP information is here, right? Like I mentioned before, it goes hand in hand with your DHCP server configuration. And then let's talk about reservation real quick. Okay. So in DHCP, let's say that I have a pool of IP addresses, right? Like 192.168.0.1 through 254. That will be the available IP address I can give to all the systems that are connected. But let's say that somewhere after you configure, you realize that, oh, I want a permanent IP addresses for my servers, right? Maybe a shared printer. So what you can do is you can reserve certain IP addresses from that pool for shared systems. We don't want those systems to renew IP addresses because we configure the other system's clients to connect to it. And if you already configure it one way, you don't want to reconfigure it every time it renews, right? It doesn't make sense. So what you can do is you can configure your server to have a reservation of a number of IP addresses that you don't want to give out, right? You want to keep those because those are going to be for your permanent system, like your servers, your databases, your shared copier, etc. And so with that, we can exclude them from the pool simply. Now, when you go through the wizard in Microsoft, it's really straightforward. It'll tell you, like, here's the scope that you're going to set up, the pool of IP addresses, and then based on that, do you want to have something excluded that's not going to be given out? So if I can exclude like 5 through 10, where I would use those for my dedicated system. So your dedicated system don't use dynamic IP. It uses static IP. Okay. And then when it talks about DNS, it talks about top level domain like your .com, .edu, .mil. This is why when you want to buy or lease a domain, right? Like if you go to GoDaddy or one of the website that actually sells you the domain, the website that you want to create, the top tier, the top level domain are higher in price compared to .io or .it or whatever, which is on the lower level domain. So there are 6 top level domains. And then sometime you would see some domain that were related to country like .us. Okay. And when we set up DNS, I'll dive a little deeper in this, and so you can see the side that you see with the security is they talk about like DNS farming, DNS poisoning. So simply, like I mentioned before, the record that it used to associate name to IP, when they do poisoning, they simply access that record and modify it. This is how they can redirect. So making sure that your DNS security is there, especially for the record for that server. Basically, it's just a file that it used to associate the public IP or the given IP to its fully qualified domain name. And if you don't protect that, right, they can poison it. And when they redirect, all your traffic goes to their server or other area, other networks, etc. Okay, and then your WINS server is here, which brings us to the last question. So WINS is still there, right? We talked about NetBIOS before because in the past, system names were the thing to use to locate system. There was no IP address. So when you set up a server, you have to set up a WINS server, WINS, Windows Internet Naming Service, which allows you to resolve system names, right, to the location of the system. Microsoft still keeps everything there, and as you go through the setup for DNS, it will ask you, do you want to keep WINS available? Now, the security side of me would say, oh, anything legacy, right, you want to omit off the list. But once in a while, you might have old systems that still are configured to be connected by name. We use a lot of the time with host name anyway, so if you can't locate it by IP address, you can locate it by name technically. So you can say, I want to be able to find that host on that network segment, and WINS allows you to do that. Okay, so they still keep it in the configuration, so you can turn it on, and by default, you just click next, it's on. Right, and then when we audit system, we would say, oh, well, why is WINS on when you're not using it? Then we can go in and reconfigure it. But any question? Okay, not too long today. So for today, for the lab, before we take a short break, you don't need the virtual machine. You can use the virtual machine. If you do this lab at home, you need to install Wireshark, which is free. I'll show you the website where you can do that. I encourage you to practice on Wireshark. The reason why I have you do this, so that way you can look at packets. In security, we monitor things all the time. If you are administering a network, you have to use Network Sniffer. One of my students, he showed me a list of the skill sets that you need to have right now for if you want to land a job as a specialist. And one of them is analyze packets and know how to use Network Sniffer or network monitoring tool, which is like Wireshark, right? The old traditional one, the name that they listed on that list was Snort, and Snort is similar to Wireshark. So I encourage you to practice Wireshark and be more comfortable with it. You can also get certification in it. Okay, so for the lab today, we're just gonna use Wireshark and to look at your protocols and the packets and information in your packets. I just did something similar with my forensic class, but they have to look at malware coming in from that packets and pull the malware from it, right? And then find out what kind of malware that is. That's usually an incident response type of task. So you might be given that if you're hit with ransomware or other type of malware. Okay, so we're gonna stop the recording and then I'll give you like about 7 minutes, 10 minutes break.